See here, I am finding two more patterns I am given for you. 9 square is equal to 81, 99 square is equal to 9801, 999 square is equal to 998001, 49 square is equal to 99980001. It is also follows some like previous one. Here if I am taking 4 nines, definitely square number getting 8 digits. 4 digits, 8 digits. In first half, 4 digits, 3 nines, 1 8. Second half, 3 zeros and 1. Similarly, if I am taking 3 nines, I am going to get 6 digits. First 3, 2 nines and 1 8. Second 3, 2 zeros and 1. And the second pattern, 10 square is equal to 100. If I am taking 2 tens square, 10, 20, again 10, 0. So the pattern like 3 tens if I am taking 10, 20, 30, decreasing 20, 10 and add one more 0 at ends. If I am taking 4 tens squares, 10, 20, 30, 40, 30, 20, 10, 0. So try to find two more subsequent numbers followed by the given pattern, like 5 9 square or 6 9 square, or you can take 5 tens in the left hand side or 7 tens in the left hand side. Like that you can check it once whether is it applicable, is it work out or not. Yes, till now we discussed the concepts which are related to exercise 6.1. I think it is very easy to solve all these problems because we learned the concepts very well. Here the first one is they are asking about the unit digits. The second one, perfect squares given reason. Is it not perfect square given reason? So depending on unit digits. Third one, square of which of the following will be the odd numbers. We know square of odd is odd, square of even is even. 4 and 5 depending on the patterns. Well, you already learned 4 patterns. We can solve this problem easily by using the patterns. Sixth one is also pattern. The seventh one, without adding, find the sum. Yes, sum of first odd numbers. 5 odd numbers, 5 square. 10 odd numbers, 10 square. See, you know how to find a number of odd numbers? For the first number, last digit is 9. 9 plus 1 by 2 is equal to 5. So it has 5 odd numbers. The answer is 5 square. For the second question, last odd number is 19. So number of odd numbers are 19 plus 1 by 2 is equal to 20 by 2 is equal to 10. The answer is 10 square, 100. So I hope you can solve the problems very less time. How many numbers lying between the consecutive squares of the following numbers? Consecutive numbers, we know that 2 times of a smallest number. First one 2 12 is 24. Second one 2 25 is 50. Third one 2 99 is 198. By seeing we are able to answer the questions. Now come to the next concept, finding square of a number. We know no kada. Square of a number means a number multiply itself. 23 square means 23 into 23. But here, instead of direct multiplication, if you want to find the square of a number, how it is possible? Yes. We need to express that number is a sum of two numbers, and after that should apply the distributive property. See the example 23 square. I am going to express as 23 square as 20 plus 3 whole square. 20 plus 3 whole square means 20 plus 3 of 20 plus 3. That is equal to distributive property. I am going to get 521. Similarly, 45 square is also 2025. So we know the square of a number in one method, that is multiply itself, and it is a second method, that is express the square of a number as a sum of two different numbers, and after that applying distributive property. So a few problems will solve by using the techniques. See 6.4.1 other pattern in squares. 25 square is 625, 35 square is equal to 125, 75 square is equal to 567525, and 125 square is equal to 15,625. Is there any pattern here? Yes. We already learned that 5 square, its last two digits are 25. See, the right hand side last two digits are, I am writing as a 25, 25, 25, 25. Then for 25 square, how I am going to get 6? For 35 square, how I am going to get 12. Remaining last two digits, we know that 25. For 75 square, I am going to get 56. For 125, I need to get 156. Yes, it's very simple. 2 and its consecutive is 3. 2 3s are 6 I am going to get here. For 12, 3 and its consecutive 4. 3 4s are 12, 12 25. For 75 square, 7, its consecutive is 8. 7 8s are 56 and 25. So, in general, P5 square. P5 means it is a 2-digit number, ends with the digit 5. Then, the final answer is P into P plus 1 into 100 plus 25. So, it's very simple. 105 square means 10 and its consecutive 11. 10 11s are 110 and add 2 more digits 25 at last. We'll get a perfect squares which are ends with the digit 5. It is one of the trick. Now, finding square of a number. Here, next subconcept is Pythagorean triplets. So there is a lot of confusion is there about triplet and triples. Triplets and triples. Here we are going to discuss about the triplets, not triples. Pythagorean triplets are the numbers that are in the form of 2m, m square minus 1 and m square plus 1, where m is greater than 1. So, if the numbers are in the form of 2m, m square minus 1 and m square plus 1, then the numbers are satisfying Pythagorean triplets. So, all Pythagorean triplets satisfy the measurements of right angle triangle. However, all right angle triangle measurements do not satisfy the condition of 2m, m square minus 1 and m square plus 1. See, m square minus 1, m square plus 1 and 2m are satisfying the right angle triangle. But all right angle triangle measurements are not satisfying this condition. Take the example 7, 24 and 25. These are satisfying the measurements of right angle triangle but do not satisfy Pythagorean triplets. Okay? I hope you understood. The next one, if m is equal to 2, in that Pythagorean triplets 2m, m square minus 1 and m square plus 1, if m is equal to 2, then among that 3 values, m square minus 1 is the smallest number and m square plus 1 is greatest number. Similarly, if m is greater than 2, so the smallest number in this case is 2m and the largest number or greatest number is m square plus 1. There is no difference in largest number, but in smallest numbers, if m is equal to 2, m square minus 1 is the smallest number. If m is greater than 2, other than 2, remaining all cases, 2m is the smallest number. So, all right angle triangle measurements are called Pythagorean triples. See the last point. All right angle triangle measurements are called Pythagorean triples. So, the Pythagorean triples are satisfy the condition a square plus b square is equal to c square. Here among this a, b, c, c is the largest one. If a square plus b square is equal to c square, then it is satisfying Pythagorean triples, but may or may not be satisfied Pythagorean triplets. See the examples of Pythagorean triples and Pythagorean triplets I am given separately. And one example is also given. Find the Pythagorean triplet if one of the number is 60. See, but it is not possible in Pythagorean triples. In Pythagorean triples, if they are given any one number, same like 12, we are unable to identify the remaining two numbers. But in Pythagorean triplets, if they are given any one number, then we can find the remaining two numbers. See, the one of the number is 60. Then I am comparing that 60 is equal to 2m, then m is equal to 30. What are the remaining two numbers? M square minus 1, that is 30 square minus 1 is equal to 899, and m square plus 1, 30 square plus 1 is equal to 901. So the Pythagorean triplets are here 60, 899 and 901. But it is not possible in Pythagorean triples. Now, find the square of the following numbers. We know you can express as a sum of two numbers, and I can apply the distributive property for the first Roman, the second Roman, Pythagorean triplets. So 6, 2m is equal to 6, find m, and find m square minus 1, m square plus 1. For 14, 2m is equal to 14, m is equal to 7, find m square minus 1, m square plus 1. I think it is very easy to solve these problems. Yes, half of the topic is completed about the squares. Now we are going to start with the square roots. It's very simple. It is inverse operation of squares. What is the inverse operation of addition? Subtraction. Inverse operation of multiplication? Division. Similarly, inverse operation of square is square roots. In this chapter, we shall take up only the positive square root of the natural numbers. Because in starting slides, we discuss about negative numbers also. 7 square is equal to 49, even minus 7 square is also equal to 49. So that 49 we can express as 7 or minus 7. Root 49 is 7 or minus 7. But here, for our convenience, and it is a fresh topic of the students, so we are taking only the positive values. And the square root is represented with the symbol of given one. See the given one, blue color one. And the definition of a square root is, if a number can be expressed as the product of two equal numbers, which are nothing but the factors, then each number is called square root of the given number. So that 64 I can express as a product of two equal factors, 8 into 8. So 8 is a square root of 64. Remember that 64 may be minus 8 also. But here we are going to take only the positive values. And root 121 is equal to 11, because I am going to express as root 121 is equal to root over 11 into 11 is equal to 11. Root 225 is equal to root 15 into 15, that is equal to 15. Is it possible to express 200 as a root value? Is there root value for the 200? No, because we can't express 200 as a product of two equal roots. 10 tens are 100, 11 11s are 121, 12 12s are 149, 144, 13 13s are 169, 14 14s are 196, 15 15s are 225. So it is not possible to express 200 as a product of two equal roots. Now, finding square roots. How to find the square roots? Yes, this first part is already again repeated here. It is coming to the note point. The square of any number is always positive. Square of any number is always positive. However, the square of every number will get one positive value and one negative value. Square is always positive, but square root will get one positive value and one negative value. We already discussed now. But here we are going to take only the positive value. The square root of a positive value is a real value, and the square root of a negative value is a non-real value. Square root of negative numbers, root over minus 64, root over minus 121. So it is non-real. We will learn this type of concept in further classes. Now, 6.5 square roots. Finding square roots through repeated subtraction method. It is another method, repeated subtraction. Do you remember that sum of first n odd natural numbers? Yes, it is n square. First odd number 1 square, 2 odd numbers means 1 plus 3 is equal to 2 square, 3 odd numbers means 3 square. So, that is every square number can be expressed as a sum of successive odd natural numbers starting from 1. Now, here we are going to apply the same logic by opposite operation. Now, I want to find root over 81. 81, what is the first odd number? Is 1. 81 minus 1 is equal to 80. Now, from 80, I am going to subtract the second odd number 3. I am getting 77. Now, I am subtracting third odd number from 77. It is 72. And continue the process till we get 0. So, I did 9 subtractions here. So, square root of 81 is nothing but 9. Suppose if I am doing 11 subtractions, the value is 11. If I am doing 15 subtraction, the answer is 15. This is one of the method to find the square root using repeated subtraction method. Second one is finding square roots through the prime factorization method. See, the number is 6. What about the prime factorization of 6? We know that, no? Yes. 6 is can express as 2 into 3. Okay, very good. What about square of a number 6? 36. What about the prime factorization of a 36? 2 into 2 into 3 into 3. Now, second number is 20. Prime factorization is 2 into 2 into 5. Square value is 400. Its prime factorization is 2 into 2 into 2 into 2 into 5 into 5. What is your observation in these two examples? Yes, the prime factors are double. In a square of a number is double to the normal number. So, 6 consists 1 2 and 1 3s, whereas 6 square consists 2 2s and 2 3s. 27 consists 3 3s and its square value consists of 6 3s. So, number of prime factors are double when we are doing the square. So, if you want to find the square root by using prime factorization method, you will find out each prime factor in the prime factorization of the square of a number occurs twice the number of times it occurs in the prime factorization of the number itself. So, P is equal to A into B into C, then P square is equal to A into A 2 times, B into B and C into C. Then what about if P is, I am going to express as A into A, B into B, C into C, then root over P I am going to take only 1A, 1B, 1C. It means if the number consists 6 2's, then its square root consists 3 2's. If a number consists 8 3's, then its square root value consists 4 3's. It is opposite operation. This is an example. 324. I am going to express as 324 is equal to 2 into 2 into 3 into 3 into 3 into 3. Now I am pairing two same factors, two numbers. So first 2 is in one bracket, next 2 3's in one bracket, 2 3's in one bracket. While I am going to finding the square root, out of 2 2's I need to take 1 2. Out of 2 3's in first pair I am going to take 1 3, and the second pair I am going to take 1 3. So root to 324 is equal to 18. So we learned two different methods. One is the repeated subtraction method. The second one is prime factorization method. Now you can solve all these problems by learnt methods. So there are 10 problems are there. Solve all these 10 problems by using of different methods. Next, 6.5 square roots, and here the subtopic is number of digits in a number and its square root. Now I am given some examples. What is the smallest one digit number? Yes, 1. Its square value 1. It has one digit only. In that, what is the highest one digit number? Greatest one digit number is 9. Its square is 81. Its square number having 2 digits. So, if a numbers are having only one digit, its square number either one digit or 2 digits. Now, come to 2 digit number. Smallest one is 10. Its square value is 100. It has 3 digits. Largest one is 99. Its square value is 9801. It has 4 digits. So, a 2 digit number consists either 3 digits or 4 digits when it squares. Similarly, the square of 3 digit number consists either 5 digits or 6 digits. So, we conclude that if a perfect square of a number has n digits, then its square root consists either n by 2 digits or n plus 1 by 2 digits. N by 2 digits or n plus 1 by 2 digits. If the number exists even number of digits, then its square root value consists n by 2. So 6 digits means 6 by 2 is 3. If it is odd, see the next previous example, 1 after 4 zeros, 5 digits are there. So the number of digits are n plus 1 by 2, 5 plus 1 by 2, 6 by 2 is equal to 3 digits. So if a number consists, a perfect square number consists 10 digits, then its square root will consist either 5 digits, half no, if n is even 5 digits. If the number consists 9 digits, so odd number, 9 plus 1 by 2, 10 by 2, again 5 digits. I hope you understood this one. And finding square roots by division method. Square roots we have learned prime factorization method, repeated subtraction method, and it is division method, which is very simple but very logical. There are very few steps are there which are most important one. Please follow the steps carefully. I want to find the square root of 529 using the division method. In step 1, place a bar over every pair of digits starting from the digits at one's place. So, give a bar for every two digits from right side onwards. In 529, right side onwards, 2 digits are 9 or 2. I am giving one pair. It is one pair. Next, it has only one digit 5. So, I am given the bar for one digit. It is nothing but 0, 5. Suppose if it is 1, 2, 2, 5, I am going to give that 1 bar for 2, 5, 12 for 1 bar. Okay. I am grouping the two different pairs. Now come to step 2. Finding the largest number whose square is less than or equal to the number under the extreme left bar. In that one, what is the number under the left bar? 5. So 5 is lies between 4 and 9. Why we are taking only 4 and 9? Because these two are the perfect squares. So 4 means 2 square, 9 means 3 square. So that 5 is lies between 2 square and 3 square. Okay. So I am going to do the division process. In divisions, divisor are given, but here we need to identify the divisor ourselves. So 2 2s are 4. 2 2s are 4. I am writing the 4 at same place under the 5 and going the subtraction. 5 minus 4 is equal to 1. Okay. Till here, I am clear. Next, what is the next step? Step 3. Bring down the number under the next bar, same like division. In division, we are bringing only one number, but here we are bringing the next pair. Pair consists 2 digits, no? So we are bringing the next pair, 2 9. Now the number becomes to 124. Till step 3 is okay. Step 4 is important one. Step 4 is double the quotient and enter it with a blank on the right. See, double the quotient means here the quotient is 2. What is the double of the quotient? 2, 4. I am writing 4 here. I am writing 4 here. See my cursor here. Double of 2 is 4. and I am giving the blank right side of the 4. Now here the next step is guess the largest possible digit to fill the blank, which will also become the new digit in the quotient. Suppose if I am taking 1, I need to put the 1 right side of a 4 and right side of a 2 in the quotient. 2 in the quotient means here 2 in the quotient. If I am taking 1 here, 1 into 41 is 41. If I am taking 2 here, 2 into 42 is 84, which is less than 129. If I am taking 3, 3 into 43, 129. So like a division, yes, 3 into 43 is 129 is satisfies. Now I am writing 1 3 which is beside of the 4 and 1 3 beside of quotient 2. So by subtraction I am going to get the value 0. So now what is the quotient here? 23. 23 is square root of 529, which is tricky, logical, but it is very simple to solve the problems if the numbers are very big numbers. Suppose if the numbers are given in terms of 8 digits or 9 digits, this method is easy instead of applying prime factorization method or repeated subtraction method. So I am given one more example, 4096. So first of all I am pairing the two digits. 40 is one pair, 96 is the second pair. 40, it is a lies between of 36 and 64. 36 means 6 square, 36 and 49. 36 square is 36, 7 square is 49. It is lies between 6 square and 7 square. So smallest one is 6 square, 6 6 are 36. I am writing 36 and subtraction I am getting 4 and I am bringing down the next pair. 4, that is equal to 496. 496. Now I am going to double the quotient. What is the doubling of 6 is 12 and I am giving the blank for the right side. That right side value I need to fill with my own values, which is satisfy the condition. What is the condition? If I am filling with 1, I need to multiply that 121 with 1. That is equal to 121. Is it equal to 496? No. So then 1 is not suitable number. Now I am going to put the 2. 122 into 2. That is equal to 244. Is it satisfied? No. 3 not satisfied. 4 yes. 124 into 4, that is equal to 496. So while subtracting I am getting 0 remainder. Therefore root over 4096 is equal to 64. That quotient is the answer. In both the numbers 529 and 6096 will have 2 digits. The square root value having only 2 digits. Even for the decimals also the process is the same, but here the difference is pair the numbers decimal from decimal to left side 2 numbers, for right side of the decimal 2 numbers from starting onwards. Whereas the left side from right to left 7 1 pair. Right side put the bar for first number 6 4 1 bar and do the operation same as like previous one, will get an answer. Whenever you are bringing down the numbers after the decimal, put the decimal into the quotient place, will get exact answer. The method is the same like normal numbers and even for decimals also. Here the difference is putting the bar. So root over 17.64 is equal to 4.2. Now the last process I think so, this is estimating square root. Estimating without solving, without applying repeated subtraction, prime factorization method, division method. Sometimes it is possible to find the square root of the perfect squares. Here I am given one example, 676. How to identify? So identify the range of the numbers. 10 square is equal to 100, 20 square is a 400, 30 square is a 900. It is a more than 676. So that 676 is lies between 20 square and 30 square. Okay. So that 670 square root value, I am getting the value between 20 and 30. If a number ends with the digit 6, then its square root value is either 4 or 6. So, either 24 or 26 are the square root of 676. 24 or 26. See the 25 square, you know how to find? 2 into 3 into 100 plus 25, 625. That 676 is greater than 625. So, root over 676 is equal to 26. Suppose here it is less than 676, like 576, then the answer is 24. This is estimating of square root when the number is perfect square. Suppose if the number is not a perfect square, see the next example, 550. It is not perfect square, but the process is same. 10 square 100, 20 square 400, 30 square 900. It is a between of 400 and 900. So 20 square and 30 square. What is the value of 21 square? 441. 22 square 484. 23 square 529. 24 square is 576. It is lies between 23 square and 24 square. So the root over 550 is between 23 and 24. And 550 is it closer to 529 or 576? 550 is much closer to 529. So the root value of 550 is approximately 23 point something something. I hope you understood this concept. And you can solve the problems by learned method. First one is a division method. Second one is find the number of digits only. And the third one is decimal numbers, square root of decimal numbers using division method. And the remaining problems also same models. I hope you understood the concepts. Thanks to everyone.